Protection of transmission line against overvoltage. Till now we have seen that we have a lightning surges, we have a switching surges. These both will cause our entire power system. So in that, basically very important part of the your power system is a transmission line, which transfer a power from your generating station to the load center via your transmission, primary, secondary transmission, and primary distribution, secondary distribution, right? Finally, the feeders which connects to the load. So I need to protect our transmission lines against this overvoltage. The overvoltage may cause due to the lightning or due to your switching surges or anything else. I need to protect my power system. So this can be minimized, or I can protect my transmission line against this natural lightning or overvoltage by minimizing, can be done by providing a suitable line design. If you have a proper line designs are done, then I can minimize this lightning surges or switching surges by providing a guard or ground wire or using a surge diverters. I can make use of any of these. I can make use of a guards here or a ground wire or using a surge diverters which will protect your transmission lines. So these protections are basically done using this method. So where it is given in the sub points, where we can over voltage of lightning stroke can be avoided practically by shielding the over voltage overhead lines by using a ground wire above the phase wire. We'll see that with the diagram in the next slide. And the next one, using a ground rod and a counterpoise wire. So that is one of a type of a lightning arrestor counterpoise wire. So a ground wire, we make use of this also to reduce your over voltage which is happening in a transmission line. We can protect my transmission line. Finally, we can include a protective device like explosion gaps or protector tubes on the transmission line and the surge diverters at the line termination and substation, where the line is ending. When you are transmitting power, if line is terminating with a load or which is terminating at a substation, in that cases also we will be protecting using a surge diverter. We will see one by one with respect to diagrams here. So this is the first one. So that is a shielding of over voltage overhead lines by using a ground wires above the phase wire. If you look at this diagram here, so this P stands for a phase of the line, okay, and so G, you can see the G here above. So this is G is a ground wire which will be connected at the top of your phase line, so that whenever the lightning strikes, it has to strike to the your ground wire, not to the phase wire. So this is how the height will be decided. Usually the height of this kind of tower will be usually this is a single tower. So usually it will be 30 meters height. H will be 30 meters height, and P is a phase here, and we have a theta S between this. So what is the angle I need to have between phase and the ground? That is called say shielding angle, theta S. So this is for your single circuit. If you take a double circuit where we'll be having a three phase here, you can see here three phases P and P and P here, all the three. So in these cases, you can see that tower will be in different shape, double tower is to say, right? So where once again we have a grounding in this way, and that shielding angle is given here, and the height once again this may depend upon your if it is a double circuit, the height will vary up to 50 meters here. 50 meters. This will be usually, if it is a single tower, it will be a 30 meters. It will be 30 meters. And there is another diagram which is shown. So this is with respect to diagram C is with respect to your extra high voltage line, where you might have observed that a very large amount of power will be transmitted using a long transmission line or very high voltage transmission line. We can say extra high voltage transmission line here. So in this case, what happens? The height of this tower will be very high. So sometimes we may have 50 meters. For example, if I take a 50 meters here, extra high voltage. So in this case, what happens whenever the lightning stroke occurs? If you observe that here, there is a lightning channel which is created here. So this lightning sometime will strike to, instead of ground, it may strike to phase also. So in this case, I need to protect my transmission line here. How actually this protection will be done? So that we'll see, I'll explain here. So these are the two cases where the protection will be done here. And this is very rare case where the lightning will stroke directly to the phases instead of the ground wire. So the mechanism by which the line is protected, which is explained here. So basically the positive charge clouds is when you have any transmission line, so where the transmission line will be very high. So suppose say I have a transmission line or tower over here. So now the cloud will be very near to my transmission line. I'm talking about a extra high voltage transmission line, not a medium voltage. Okay. In this case, what happened? The positive charge cloud will be having a positive charge cloud, which will be assumed to be above your transmission line, which will be above the transmission, very near to transmission line, I can say. So this includes a negative charge on the portion below it of the transmission line. So here we may have a negative charges over here, having a negative charge. Obviously, so due to this, the over voltage will be present within the line and your cloud here. So whenever, if we have a ground wire is present within a transmission line, if this is my, this is a phase line, which I'll write with the red color here. This is my phase wire and this is my ground wire. Let me take with a green color, so to just differentiate. So now, so this negative charge will present here across the phase. So this won't be here. Okay, this won't be here. So it will be over here. So now this charges will try to flow from positive to negative to the transmission line. So where if you have a ground wire, so where if you have a ground wire at the top of your phase wire, what happens? So then whatever the charge will present will directly go to the ground wire and the line conductor will get induced charges. So it won't be having a direct connection between your cloud and the phase wire. There will be only induced charges to be present within the transmission line. And the ground wire will be earthed to at a regular interval. If you look at here, so they are shown entire thing has been grounded here from here to here. So usually what happens at a regular interval, if this is your transmission line, so they will be grounding at this point, and if you go for other span, at regular intervals, the grounding will be done for a transmission line. And it won't be done for one point. If you look at your transmission tower, where the towers will be having a 4 legs, right? So usually it will be in the 4-leg fashion. For all the legs, the grounding will be done, because whenever there is a fault occur or a lightning stroke occurs, the lightning should go to the ground through a ground wire or through the pole itself. So that's the reason the pole also will be done with a grounding. So apart from this ground wire, where this ground wire will carry one line, which will be grounded directly to the ground. So apart from this, the tower also will be grounded here. All the 4 legs of the tower also will be grounded. So in the next case, we'll see that there is one more called as a counter poise wire, and other things are there that also will help to ground the transmission towers, so that if anywhere the fault occurs, it can easily be grounded, so that I can protect my transmission line here. So here, whenever this lightning stroke occurs on our transmission line, which will be transmitting to the ground through the ground wire, and only the induced charges will be present on the phase of the line. So this potential difference between the ground wire and the cloud, and between the ground wire and the transmission line, will be in a inverse ratio of the respective capacitance of the line. So what is the potential difference between your ground and the cloud wire, between these two, and between ground wire and transmission line, between these two, as well as between this cloud and ground wire and phase wire. So this will be the inverse ratio of respective capacitance of the transmission line. So the voltage difference will be inverse to the capacitance of the transmission line here. So the ground wire which is near to the line wire, which will be having a induced charges on it. So if you look at here, so your phase is very near to the ground wire, right? In this case. So in this case, we may have induced charges on the phase also, which will be having very much less induced voltage, because maximum voltage or maximum power will be flown to the ground through the ground wire. So only few amount of induced voltage will be present on the your phase line, and hence the potential rise will be very small on the transmission line, so that the transmission line will be protected by using the ground wire. And usually the shielding angle, the theta s, will be considered as a 30 degree. The shielding angle theta s, which will be considered as a 30 degree here. And for extra high voltage line, so the proper design need to be taken care. Usually it will be having a 50 meters height transmission line. So in that case, the lightning will be lightning stroke occurs that will be directly exposed to my phase of the line as well as the ground of the line. For that reason, the shielding angle and the flashover rate and the failure probability will be very, very important while designing the transmission line. So they will consider flashover rate. In that area, what is the flashover rate? How many times within a year, what is the interval of, what is the rate of flashover is going to occur there? And what is the failure probability? Whenever the lightning occurs, transmission line get failure, what is the probability of that? So they will, and also what should be the shielding angle. So these three parameters will be considered while designing a this kind of high voltage, extra high voltage transmission line, where the lightning strokes are more in that area. So that parameter will be taken care, and they will do the design so that I can protect my transmission line even with a normal ground wire or a shielding by the ground wire. So this is the first one. The second one, that is a protection using ground rod and counterpoise wire. So that is, you can see in this diagram here. So whenever the lightning stroke occurs, this high voltage has to be drained to the ground using two paths. So the first path will be through the tower frame to the ground through the ground wires. There are two paths. So if you look at here, this is my transmission line here. So these are the transmission line, and here we can see this is called as a counterpoise wire. For all the transmission line, so there will be a wire. So if any ground is failing within a one transmission line, it will be connected to the next transmission line, and this entire counterpoise wire will be connected to the ground here at the equal interval once again. So not only grounding individual tower leg also, we will be grounding to the counterpoise, and it will be connected to the tower also. So that whenever this high voltage is presented within a power system or transmission line due to the lightning, so it can easily drain to the ground using your tower frame or through your grounding wire. And the last one, that is a protective device, making use of a protective device. So as I mentioned, we can protect the lightning stroke using different kind of protective device. There is a shunt protective device, explosion gaps, protective tubes, rod gap, surge arresters. So all these are made use in the power system for a transmission line to protect your transmission lines. So these are the diagram for this one. This is a explosion gap, this diagram. So where usually in your syllabus, these diagrams are not given, just have been shown here to relate that how actually it will be present, how it can protect our transmission system. So if you look at this, there are parts are given, the external series cap, upper electrode where the transmission line will be connected, and the ground electrode where the ground will be connected, and where we have a fiber tube at the side of these electrodes, and we have a hollow space within the center of this explosive gap, that is called as a gap. So where any spark occur, the spark will be initiated within that gap. So that is called as a explosion gap here. And the second type, it is a another one, that is a protection or protective tube type. So here we can see once again the parameters are given within this. The one indicates the line which will be connected here. So this is a suspension type insulator is here. So you can see this suspension type insulator. For that, the line is connected. You can see one which is indicating a round mark. So that way I'm seeing with a front view of a transmission line. So one is a transmission line and two is a gap which will be presented at, that is called a series gap. And third one is a protector tube. So where the spark will be protected using this tube here. And the fourth one is a ground connection where I can connect to the ground. So if there is a high voltage present, it can directly go to the ground. And similarly, there are cross arm which will support your transmission line via your suspension type insulators here and the tower body. So if you look at any transmission line, so that will be protected using this kind of protective devices to protect against the over voltage which is happening in a transmission line. So this is regarding protection against over voltage for a transmission